Today I'm going to show you a simple hybrid Kubernetes cluster using the Hyper-V with the Windows and Linux nodes. The audience of this video is the people who want to create a lab environment using Kubernetes and play around with it, and this setup is not intended to use for production. You will see how to set up the Kubernetes master node on Ubuntu Server 20.4, how to configure the CNI using the Flannel, setting up the Linux and Windows node and join them to the cluster, and at the end we do some simple deployment testing. What you need to know, you need to have a basic knowledge about the Kubernetes. You need a Windows server with the Hyper-V enabled. You need at least have 8 GB available memory, preferably 16 GB of RAM. And for the software, you need Windows Server 2019 with this build number or higher. Ubuntu Server 20, and yeah, of course, Hyper-V Manager and SSH client. Our setup will be really simple. We will have only one master node in the cluster with the 2 Windows node and 2 Linux node. And as I mentioned before, we will use the Flannel as a CNI. Currently, there are multiple CNI available, like Calico, Wave, Rancher, and some more. To keep the setup simple, we will use the Flannel with the hosted gateway or L2 bridge, so we can have a mixture of the Windows and Linux container in one cluster. We will do everything step by step. At the first step, we will install the Ubuntu. We will install all of the necessary components on that, and afterwards we will create some template or image from it, and we will use this image or template to set up the master and to Linux node. For the Windows, we will do the same. We will use a clean installation of the Windows Server 2019 with all updates installed. And we will install the Docker and required services on that. And we will export the VM, and we will use it as a base template to create our 2 other Windows node. And later we will get them to join to the cluster. That's it. Let's start with the Ubuntu installation. Ubuntu installation is pretty straightforward. I will create a virtual machine. We will use the first generation. It's 4 GB of RAM. I have already downloaded the Ubuntu server. Kubernetes needs at least 2 core CPU. I will specify 4 for the master. Need to change my keyboard layout. I will install SSH server, and we don't need anything else. So installation is done. To reboot the system. I have the IP address here, and I will use the SSH to connect to the server. I have already provided the necessary scripts and the steps on the GitHub. So first we need to make sure everything is up to date. Afterwards, we are going to install Docker. The rest of the tools are just for the diagnostics if it's needed. They are not mandatory. Afterwards, we will add the Google GPG keys and the Kubernetes repository. Afterwards, we are going to install the Kubernetes components, kubelet, kubeadmin, and kubecontrol. We will set a kube component to, we will mark them as hold, so we prevent the accidental update. So what we need to disable the swap. You need to make sure that in this file, the line, the swap line is deleted. And as we can see here, it's deleted for now, so it's okay. Afterwards, we're doing the return of the swap completely for the system. For the Ubuntu, we need to make sure that it is able to see the bridge traffic. So we need to add this line, net bridge, and I've called IP table equals 1. We reload the system. And for the Docker daemon, we need to make sure it uses the correct driver. Afterwards, I reload the daemon and restart the Docker. At this point, we are done. I'm going to shut down this system. Now I am going to export this and use it as a template or image for other nodes, master nodes, and every other node. So export is done. I can delete this. Now I'm going to import it 3 times, 1 for master and 2 for 2 Linux nodes. For importing, I will use one PowerShell script. Use the script, we need to know the BMCX file. We can take it from the location that we have exported it. In the virtual machine folder, you will find this file with the extension of BMCX. And what we need to do, we will use it like this. We want it to be in D, and the name will be C1 M1, and the path of the VMCX file. It'll take a minute or two. So the first one is there. We will use it for the master. And the second one will be for the Linux node 1. The second Linux node. So basically we have currently 3 machines, and everything, almost everything is installed on them. We will continue with the master node. IP is changed. So first, we will going to rename the host and add some host entry. Okay, C1 M1. That would be the first master for the cluster 1. I'm also going to specify the static IP address for this. So we need to, Ubuntu 20 will use the net plan, and for that we need to change it. And I will reboot the system simply. Well, we have a static address, IP address, and now we can initialize the cluster. To do that, we will use the kube init command, and I will specify the path network, etc. So the initialization is done. We need to create these directories and copy the kube config. You may want to note down this kube join command. So you can use it on other node to join to the cluster. Afterwards, we are going to download the Flannel configuration. And we need to edit it. And here you need to search for network configuration. and update it to the IP address, say there that you specified in there with the Kubernetes. And here we need to use the hosted gateway. So I can save it and apply it. When it's applied, we can check if the pods are creating correctly. Yep, the kubeflannel is there and it's running. And afterwards, we need to download the correct version, the Windows version for the Flannel. You need to specify the correct Kubernetes version in here. I use the 123.1, so I will specify the same in the URL. So it's done, and after that, we will use the hosted gateway version of the Flannel. I need to apply that also. And I will configure the rolling update for the kube proxy. And to check if everything is correct, we will use this. And as we can see, we have a kube proxy and also the kube proxy for the Windows. And Flannel and Flannel for the Windows. The important thing is the selector in here should be correct one. So that's it. The master initialization is done. And now we are going to join the other nodes to the cluster. For the Windows nodes, I am not going through with the installation and the Windows update. I already have exported virtual machine and I have imported here. It's a fully clean installation without anything extra. So I bring it up and we will check the version. The release ID is 1809 and the build number is 763. So the first thing we need to do is installing the Windows containers. And afterwards the Docker module. And now the Docker. And install the Docker service. We set the startup type to automatic and restart again. And here we will download the script for the SIG tools. And now we will shut down the VM. And we will export it. So now I can remove this from. And I will import it 2 times for the 2 Windows node. So now we have imported the Windows nodes, and for the each node first, we're going to rename the computer. I'm going also to assign a static IP addresses to them. I will specify the static IP address for the Ethernet. 75. Also set the ENS. The same for the other one. At this point, it's a good idea to create a checkpoint before joining to the master, but it's up to you. So to join to the master, we will go to the directory that we have downloaded the Seja script. And we need to specify the Kubernetes version, in this case as this one. Kubernetes Kubernetes version 2.1. And here now we can run the join command node that we have copied from the master. And now we go back to the master. Get now it's the first node is there. It's still not in the ready state. can do the same for the second node. And the second node is also there. It will take a few minutes till they come up. Meanwhile, we will continue with the Linux nodes. I've already imported 2 nodes in there. Okay, the first node is ready. Both of the Windows nodes are ready. So for the Linux node, we will going to change the host names. And I will assign the static IP addresses in there and reboot the system. Do the same for the other one. And we can use the same join command. We check the master. So the both of the Linux nodes are there, and we have also both of the Windows nodes. So I will edit to show us everything in here, and I will open another session. And to test the cluster, I have already 2 sample deployment file. These are really simple deployment files, and here what is important is the node selector. You need to specify the correct node or correct operation system for them. This one is for the Linux. It will be deployed to our Linux nodes or Ubuntu nodes. And this one is using the Windows Server 2019 image, and it will be deployed to our Windows nodes. So I will download them and we will deploy them for testing. That's the first one. And the second one. So it's all. So the first one will be deployed to our Windows nodes. As you can see here, it will take a little bit time to all the images are running and the service is also up. So we should be able to call this. For the port 8000. As you can see, yep, it will print out the operation system and the IP of the pod, and that's from the second one, 241.4 and 242.4. That means the load balancer is also working correctly. We do the same for the Linux. And the service IP is this one. It's running on port 8000. Yep, the 3.2, 4.2. And that means everything is working fine. What's important is to check the connectivity also inside the pods. To do that, for example, we will use the Windows pod. Now we are inside the container, and here I have the CURL. And from here, I will call both of the services. That is the Linux port 8000. And we get the answer. That means the connectivity between Windows pods and Linux pods are working. And we do the same for the Windows pod. And it's also working. We can do the same test also for the with the Linux pods. That means this time we will use one of this. And they are Alpine image, so I will use some. And we do the same test here. It's working, and answer this one. And it also works. That means we have a full connectivity between the Windows node, Windows pods and Linux pods, and there are also connectivity between the nodes. That means from the master, I can call the Windows nodes or the pods that are running on the Linux. You could also test the connectivity for the individual pods like this. I will use the direct IP address of the pod. They are running on the port 18, so we will get the answer from them. So that's it for the testing. Now I am going to show you some useful command and case that you need more information about your cluster, or if you run into some sort of the problem. So with the cluster info dump, you will get the information about your whole cluster. You can run this on the master. If you need only the uh, cluster IP range, you can run it like this. If you need the services IP range, you can run this command, or if you need to find out where is your DNS, you can run this one. You need to run them on the master node. So as you can see, you will find out the IP addresses that you need, and here at the end, it's the DNS IP address. Sometimes you have some problem like the nodes are not reachable, or nodes doesn't come up, or they say on not ready status. In those cases, you can use the describe node command, and you will see more information about that node. And here, if you have some error, you will see it in here. You can do the same for the every service, like nodes, pods, services. If you wanna see the events, you can check the events like this. It will show you the events of the whole cluster. If there is some error, you can delete the deployment and services when you're done with them, or if something's went wrong and you need to redeploy them. Uh, if something goes wrong with the initialization, you can use the kubeadmin reset. Or if you want to remove the nodes, or if something went wrong with the node and you want to rejoin them, it's a good idea to first remove them from master. To remove them from master, first you need to drain them, and you will tell the Kubernetes to remove all local data, and if there is a deployment or pods on them, on those nodes, first you can drain them. And afterwards, with the kubectl delete node, with the node name, you can delete the nodes from the cluster. That's all for now. You will find the GitHub repo URL in the comment section. Thank you for watching. I hope you find it useful.